I will be speaking about the practical sides of streams. So first things first, who here knows what streams are? More or less. More or less. And who has ever used streams? And using it in your everyday job? Okay, yeah, that's what I hoped for. So this presentation is for you. Basically, I want to implement a web game in streams, and I will be introducing a new streams concept as we go, so that you can know some operators that we are using in order to implement the game. And we'll be creating a classical snake game. So bear with me. For all of you who haven't risen their hands, I have like 5 points for you to take away from this talk about why streams are cool. So the first thing is, what are they? They are really the same. So we are doing the same thing with streams that as we've done so far, but in a different way. So this is another different way of defining application logic. And what's different about it is that it's focused more on the data transformations. So by data, I mean the usual suspects like arrays, lists, ints, strings, and so on, but also code. So you can have a stream of functions, which I will show you. And you can see, you will be able to see how and when can it be applicable. You can think about streams as unbounded collections. So they have a beginning somewhere, but most of the streams don't have really anything at the end. And also, streams help us fight with our worst enemy, the programmer's worst enemy, which is time. So when you're programming using streams, you don't really focus on why and when and how. You focus on what. So you just describe what should happen, and you don't care about anything else. So time, we can say that time is hard-coded in streams. You'll also see that. And of course, all those things make up as one definition, which is declarative. So when you are doing something in streams, so programming streams, you are programming declaratively. So you don't program the algorithms, the step-by-step, what should be done by your code, but you just program descriptions. And those descriptions are later on transformed into a running code. And this is a notation I'm going to use, the image at the bottom. So this is a stream, and time runs from left to right. And that's all you need to know for now. And there will be lots of this kind of diagrams throughout the presentation. So what you will learn? You will learn just one thing after this presentation, I hope, how the application that is written using streams looks like. So this is all I can believe you can take from this presentation. Whether you have a positive or negative opinion, it doesn't matter to me. Once you have an opinion, I will have done my job well. Okay, so let's prepare the battlefield. The battlefield is this React component, which I will show you code later. It doesn't matter right now. So this is an empty board, and we can draw snake, which is 1 point right now, just one pixel, and the red dot is fruit. So the snake will have to eat the fruit, and this is the whole game, right? And here's our first stream, the main character of the show. So this is a stream of empty objects. So that's why those circles are empty. So this means that the objects are empty. What is cool about the stream is that those empty objects are produced in the stream each 100 milliseconds. And we'll call this stream ticks. So what we can do with this ticks stream? At the top, you have an input stream, which is our tick stream. In the middle, you have an operator, stream operator, the first one that we are going to use. And I will introduce to 6 of them. So this is the first one, map, the most simple one. And in this case, map gets a function. This function transforms any object from the input stream into a vector 0, 1, so the constant vector. And what we get is an output stream, so a whole new different stream, which each 100 milliseconds outputs vector 0, 1. So any questions about that? Okay. What's next? So we have our direction stream. So why have I done that? We created a new direction stream. So for now, we don't care about user input. For now, we just want the snake to move in one direction so that we know that everything is set up correctly. And then we will iterate and do a better game. But for now, we just want snake to move in this direction. This direction means that it will go down. Okay? So we want to create a new stream. This will be called snake heads position stream. So each time a new snake position, head position, so the first pixel of the snake should be created, this will be outputted into our new stream. So as you see, this is the most complicated operator I will show you, and it's called scan. And scan takes two parameters. And the first one is the initial value. In this case, it's 0, 0. So the new output stream that we'll create using this scan operator will have 0, 0 as the first value. And what scan does is it accumulates all the values from the input stream, so our direction stream in this case, into one value. Using the function we provide as a second argument, which is just adding direction to the current position, to the accumulator value. So as you see, the second parameter is just a function, two parameters. It takes two parameters. One is the pos argument, which is the current accumulator value from scan. And the second one is their direction, so it's an element from the input stream that triggered all the operation. Okay? And as you see, we have an output stream that has a new position each time the 100 millisecond passes. It has a new position of snake. Any questions about that? I want you to learn something, so please, if you have any question, it's very probable that 2/3 of the whole room also has this question, but it's ashamed to ask, so please do. To sum up, those two operators, map and scan. Map transforms the value from the input stream and outputs the new transform value to the new stream that is created. And scan accumulates the values from the input stream using the function and init value that we provide. Okay? And here's how the code looks like, and it's real code. So I've shown you 3 diagrams, and this is Bacon.js implementation. So as you see, the first line is just creating the stream of empty objects each 100 milliseconds. The second line is creating a direction stream. As you see, we are providing a function which returns 0, 1 vector each time the new value in ticks appears. And the third statement is snake head positions. So we scan over the direction stream and accumulate the position of a new snake head. Any questions about that? Okay, so one more line, and we can see that this is like kind of working game, right? So we cannot control the snake yet, but still it moves somehow. And what we did is we just each value from the snake head position stream, we just piped into a display function, which triggered the whole React component redrawing in this case. So as you see, just those 4 statements, and it's enough to just have a dynamic game. So kind of. Okay. So 2 features about streams I'd like to highlight right now. The first one is that they are reusable. So what we can do also with the snakehead position stream, besides displaying it, we can also send it to server or persist it. And exactly the same stream will be used. So they are reusable. So the same value, if the value appears on the snakehead position stream, it will be piped into those 3 functions that we provided on value. And value means also subscription. So this is the first thing, streams are reusable. And the second thing is that if there are no elements at all, so nothing is going on in the stream, then really nothing is happening in our application, no CPU or things like that. So for example, if we don't have any subscription, any on value function, then nothing will be happening inside our code. So that's cool, right? So let's try to make our game really real game. So let's create another stream, which in this case will be a stream of key presses. So each time a user or player, maybe not player yet, but the user for now, presses a keyboard key, the value appears here in this key presses stream. And the object in the stream is just keyboard event. That means that a key was pressed. What we can do with that? We can, of course, filter. This is a third operator. We can filter the input stream. In this case, all the keys that are pressed are in the input stream at the top. And we can filter to create a new stream, which will be left key presses stream. And we filter just the key presses that are left. In this case, and right key presses, also another stream, right key presses, and those two streams will be the whole input to our game. So we will be creating some kind of Nokia classic Snake when only rotations are possible. So again, we've already used map and scan, and there is a third operator from 6 that I'm going to speak about, and it just checks whether the predicate that we passed is satisfied by the values from the input stream, and all those values are spit out into output stream. So now here's the tricky part, so please pay attention, and if you have any question, just raise your hand or shout out. Okay? Input stream is our left key presses stream, and what we are doing here, rotate left is a function. Rotate left is a function which gets a vector and returns a vector that is rotated to the left, 90 degree. So what's happening here? We are mapping over the input stream of left rotation, and what we get stream of functions. So now the output stream, which we'll call the left rotations, this stream has a value, which is a function, each time the user presses a key, left key in this case. Okay? So each time user presses a key, there is a function in this left rotation stream. We can do the same thing for right rotations. So we have two streams, left rotations and right rotations. Those are streams of functions. And we can merge them and create an action stream. And what action stream does is that each time user wants to change the direction that Snake is moving towards, then this new stream will output a function that we need to use to change the direction. Okay? So a little bit tricky, but very, very helpful, as you see. Any questions about that? Okay, so let's sum up. Merge takes two input streams and merge them into one stream. So each time a value appears on the first input stream or the second input stream, also this value is outputted into the output stream. So recap. What we have right now, and we'll be changing it to get user input. So this is what we have right now. We have a direction stream, which is only like 0,1 vector each 100 milliseconds. And we are creating a new direction stream, a better one probably, and it just takes an action stream, so the stream with the functions, and scans it to get a new position, a new direction. So what scan does, again, it accumulates a value, so it gets an initial value. In this case, 0,1 is the initial direction in which at the start of the game the Snake will be heading to, and a function which accumulates a new values into the current accumulator direction value. So in this case, as you see, we just apply the function to the direction. And for example, 0,1 is the first output stream value because it's an initial value. And then when user presses the button, the action stream has a new value inside it. It's a function rotate left, and we just apply this function to the current accumulator value, which is 0,1, and we get 1,0. And again, user presses again the button, and still the accumulator value, which is different right now, is applied to this function, which is provided by the action stream, and then 0 minus 1 direction is outputted to the new direction stream. Okay, is that clear? How can we use that? So this is what we had already. So 0 ones each 100 milliseconds. And this is what we have right now. So we have a new direction stream which gets user input. So it's a game. But what's wrong with that? Who can tell me? Sorry?
The snake is still only 1 pixel away.
Yes, but what else? What else here?
You can make many actions in turn.
Yeah, so basically what's been happening so far is that 100 milliseconds was the tick stream was outputting a new value each 100 milliseconds. So the snake was moving down, right? Because each new object in the tick stream was triggering the change of the position. But here, the snake only moves when user presses the button. And we all know how snake works. So we can press a button, but the snake should move without any more button press. So somehow we lost track of time. So we have a right position, so the position that the user has chosen, but we can't move the snake forward. So what we can do is we can use another operator, which is sampled by, and it does exactly what it says. So it takes two streams. The first one is the streams of values. In our case, it will be just direction streams. And the second stream, which just samples the values from the input stream. Okay? It samples the values. So whenever a value appears on the second sampling stream, the last value from the first stream is taken and outputted to the output stream. All right? So how can we use that? We can, of course, sample our new direction stream. So we are taking our ticks, so the tick stream, which is empty object each 100 milliseconds, as a sampling method. So each time a new value appears on the sampling input stream, we get a new value for our new stream from the last value from the input stream. So in this case, as you see, 1 direction has been lost, right? Because user pressed the button so quickly that two value changes were done inside 100 millisecond window, okay? And as you see, only 0, 1 was outputted, and then 1, 2 vector. Okay, any questions about that? There will be a quiz in a minute, so you better pay attention, okay? So is there any questions about that? Okay, I told you before that streams are reusable, and we just were playing with the direction stream. What we can do only, what is sufficient for us to do, is to just replace the old direction stream with a new one, and the rest of our code is left intact. So the position stream, in this case, will be the same. We'll just replace the input stream with our new direction stream, and that's all we need to do. And that's how the code looks like. So this is the whole code from the key presses. So as you see, we create first the keys stream, then the lefts and rights are done by filtering. Then we do left rotations, which are just streams of functions. We merge them into streams into action stream, and then scan over them, and we have a new direction stream, which outputs a new direction each 100 milliseconds, and this direction is really triggered by the user. Okay, and this is how it looks like. So still, the snake is only 1 pixel big, but we just needed 10 streams in order to achieve that. It still cannot eat any fruit, but we'll get to that in a minute. And we've used 5 operators so far. So is that all clear for you guys? Okay, so let's make the snake bigger. There is another operator, the last one I promised, so it's called sliding window. What it does, each time a new value appears on the input stream, it outputs last n values. So n is a configurable number that we provide. So in this example, for example, we were creating a snakes stream, right? And we have our head position at the top, and the sliding window with 2 means that we want to create a array of last 2 elements from the input streams, from the input stream. In this case, it will be 0, 1, 0, 1, 1, 1, 1, 1, 1, 2. And this stream will be called snakes stream. So we have an array of last n values that the snake has been on in the last few turns, ticks. Okay, and now a quiz. So how can we, using only the operators I've described so far, and only the streams, reusing the streams that we've defined so far, how can we implement eating of a fruit? So it's just one word, you know. You just shout it out. What operator should I use? Wrong. Wrong. So five guesses left. Sorry? No. 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 Filter. Good. Yeah, we can use filter. So we have a snake's head position as our input stream, and we have a fruit position. This is a constant for us, right? In any given time. So we can just filter the head of the snake with our function. We just compares the head to the fruit, and anytime on the output stream there is a value, it means that the head is on the fruit position. That means the snake has eaten the fruit. Okay. Okay. Now I will show you the real implementation. It's in total it's not even 100 lines of code. So this is a static board I was talking about. This is 30 lines of code. It just renders a snake and a fruit, which are given from the outside. And so this is the first React component, and this is the second one. So all those things, as you've seen, ticks, keys, left, right, snake head positions, all those things are here. And this is our fruit eaten events, which is just filtering. Okay? And is it working? As you see, this is the code I've shown you. Yeah. So no more than 100 lines of code, including drawing, is enough for us to implement a thing like that. Okay? Cool or not cool? Okay, and when you use streams, you can just draw architecture like you always been doing. But in my opinion, this one is better. So flow. You basically just draw a flow on the whiteboard, and you can figure things about that. For example, in our case, we have just 2 input streams. The first one is ticks, which is just objects that are empty objects that are produced each 100 milliseconds, and the keys ones, the key streams, which is produced by the user. And the rest of the whole flow is just reusing the existing stuff using the operators. And the arrows here mean that we are using some kind of operator. Okay? So you can see the client code and play with it. There is also a multiplayer version, and there is a server code for that. It also was written using streams only. So WebSocket was created on the server side, and on the server side, I've just created all the stuff using streams, but on the server side in different technology. So only for the brave ones, okay? And there is a site called RX Marble, so the second link. You can play with the stream operators. So Bacon.js, RxJS, Kefir, all those libraries share the same amount of operators. Maybe the names are different sometimes, but basically it's the same kind of semantics. So you just play with them by dragging around the values from the input stream, and you see how the output stream changes for each of the operators. So I really recommend you to use this site. And Bacon.js it's what I've been using. And also there is a live coding talk, which I did on Kraków meet.js. So it's 1 hour long, but from the scratch. So you can see how quickly it can be done, really. And one more thing. So if you like streams, let's assume that. So you are using Bacon.js or RxJS or something like that. And you like virtual DOM, because React.js has virtual DOM, and it really plays nice with the whole software development process in your company. And you like types, because, for example, types lets you write less tests, unit tests, because compiler does some of them for you. So if you do those things, then you probably need to check out Elm. Okay? So just to wrap up, please, if you like those 3 things, take a look at Elm and let me know if you really liked it, if it helped you in your software development. So my name is Michał, this is my blog, this is my Twitter handle, and thank you very much, guys.
Thank you for your presentation. It was amazing. I've got a simple question a bit above of what you were talking about. Can you give some real-life examples of using streams like in front-end applications and so on, not concerning a game, but more general?
Yeah, of course. So I'm not just talking about from the experience from the Snake implementation I did. Maybe some history. I have like 2 minutes. So we are using streams and Bacon.js and React.js in our real application in Okado technology. When I was introducing it to my team, I did a workshop, and the Snake is the workshop. So we've done like 3 hours workshop to implement Snake just using streams. And we are using streams to and WebSockets in order to push events to our browser, because the browser is not a real CRUD application that's like the most popular. In our case, it's just displaying things to the user most of the time. So streams are, so the GUI module is just like a module, not the main part of the application at the top, but just a module. And our backend server just pushes events to it, and they are displayed for the user. So we don't care about the GUI so much. It just renders the data that we are pushing to it. So this is a real-life example. This is a real production software. Any more questions?
Hi, thank you for the presentation. What is the performance behind streams? How many streams can you create not to hinder the performance?
Okay, so we just did a performance test for our case, for our usage. And what we did, we were mostly concerned about a performance of the memory leaks and things like that. So if it's slower than we want it to be. And we wanted to have like 100 events per second on the real like kiosk Google Chrome OS kind of hardware. So 100, so this is not much, but what we wanted to do is that we wanted to have this browser running for like many months without restarting it. So we did a test like that, not months, but days, like 20 or 25, and just monitored how much the memory is changing or memory consumptions, things like that. And in terms of Bacon.js, I know that for RxJS it can be different, but we chose the Bacon.js because it's a really small library, no glitches and things like that, and also it didn't have any memory leaks. So what we did is for 20 days it was running at the constant speed, which was just constrained by our application logic, so the functions that we did, right? Nothing more.
Okay, thank you much for presentation again. If you have another questions to Michał, please ask them.
I will be around. I'll be around.
He'll be around.
Yeah, okay. And if you want to play with it and code something and see the code for yourself, just grab me here or after the presentation. Thank you very much, guys.